Hello everyone, welcome back to Smart Extension Services. Today we have a very interesting topic to discuss on, and it's drawn from part 1 of the previous video where we had discussed the growth performance of doper sheep fed on rangeland grasses with legumes. Using the same setup of the experiment, today we'll focus on enteric methane gas emission. So let's go straight to the results.
Giving out results on enteric methane emission from sheep fed on grass alone or grass legume mixtures. This experiment was set up in Kasingau, the one we have had on the performance. At the same time as you are doing performance, we are quantifying the emission from the animals. On background, we are aware that of the global warming and climate change, which is a very big challenge nowadays. And much of the emissions or the greatest contributor to the global warming is livestock, particularly the ruminants livestock through enteric methane emission. And livestock sector as a whole is responsible for 35 to 40% of methane emission, enteric fermentation. And ruminant, they produce 2.7 gigatons of carbon dioxide equivalent. And of the 2.7 gigatons, cattle is responsible for 77%, small ruminants 9%, and buffalo 14%. What is this enteric methane? This is a byproduct from digestive process of ruminant during the degradation of the feed in the rumen. One of the product is methane, which is emitted through and is emitted to the atmosphere through belching, and to a little extent through the hind gut. So the amount of enteric methane which is expelled by the animal is related to the amount of feed the animal has taken, and the amount of feed taken depends on the animal weight, the level of productivity. That is, high producers will take more feed. The environmental factors like temperature, reproductive status, the high producing animals will tend to take more feed, and the quality of the feed. So between 2 and 12% of the energy intake, what animal has taken, 2 to 12% is lost as methane. And these 2 to 12% could be of use as in production, either production of milk, in reproduction, but it comes as a loss through emission. Why enteric methane is important? First, it is the second most important greenhouse gas after carbon. We have 3 major greenhouse gases, that's carbon dioxide, nitrous oxide, and methane. Methane is the second most. The first is carbon dioxide, then methane, then nitrous oxide. And methane has a global warming potential of 28 times than carbon, and it stays in the atmosphere for between 12 to 15 years. Earlier, I've said much of methane is from the rumen, but hind gut also produces methane during gut fermentation, 13%, and 87% is from the rumen. And I've also said it represents a loss of energy. As the animal belches and releases methane, that is the energy lost, gross energy lost, which would have been used in production. So reducing this emission, it will help us in reducing the rate of warming in the near future, and also sustain the peak warming. So that is why we try to quantify and come up with strategies to reduce the emission and enhance nutrient utilization for sustainability. And some of the strategies include animal manipulation, that is in animal breeding, and dietary manipulation, that is where this project was, that is in terms of forage quality. We try to give our animals the best, improve the quality of the feed using legume to reduce the emission, and then rumen manipulation. Those are some strategies, but here, why do we need to mitigate methane? Because when we have less methane in the atmosphere, it will mean the concentration of methane is reduced and less emission or warming of the atmosphere. Also, less methane will mean increased efficiency of livestock production. And if the efficiency is increased, our productivity will increase and we'll have high income. So in expressing the emission, this is science. So the emission is expressed in terms of a yield. In yield, we use dry matter intake, grams of methane. These grams of methane per kg in dry matter intake, per kilogram of what an animal has taken. We can also express it in terms of density. That is per kg of production. That is per kg of milk, per kg of meat. Grams of methane per kg of meat produced, per kg of milk, like that. So the objective of this study was to contribute to sustainable livestock production in the rangeland ecosystem through estimating the enteric methane emission of small ruminants, in this case sheep, fed on grass alone or grass mixed with legume in the ratio, as we have been told earlier, the ratio 3:1. So the site, we had a similar study, Kajiado, Narok, and Taita Taveta. In here, Taita Taveta, it was set up in Kasigao. You know the setup. It has been explained during performance. So the animals used were growing sheep, which was between 12 to 15 months. And average live weight was 22. The diets used for Taita Taveta, it was Sengras cerealis, as in grass alone, and Sengras cerealis and Ropong bushirai, that is grass alone, or mixed with legume. Bushirai, foxtail mixed with either dolicos or cowpea. And the period was 91 days. And the parameters we measured were live weight of the animal. We took the initial live weight, and then live weight was collected weekly, every week. We collected live weight. Then intake daily, or the feed offered and the refusal was also collected. Then the nutritive quality of the diets used was also measured and analyzed using wet chemistry. And then we calculated the live weight gain, and using this methodology, this formula, Tier 2 protocol, which is in the IPCC, we calculated the amount of methane produced. And the analysis was through GeneStat. So from the results, in Taita Taveta, the intake increased with the inclusion of legume. The intake increased. And methane production, that is in grams per intake, reduced with the inclusion of legume. And also the dairy methane production, that is amount of methane in grams produced per day, also decreased with the inclusion of legume. Being cowpea, it increased from 0.8. Then the methane production in grams per day, it reduced between 15.63 to 12.9. And the yield in terms of packaging dry matter intake, it decreased by a certain percentage. That implies that including legume will help in reducing the emission and also the warming of the atmosphere. So the conclusion of this story is that the methane production and methane yield decrease with addition of legume in the diet. The quality of the diet offered influenced the intake. We have seen, including legume, the quality increased and intake increased. And also, the emission decreased. The take-home message, it is important to supplement our livestock with protein while feeding to enhance production, increase income, and reduce the emission. The lower methane emission generated in legume grass-based system is thus a good option in achieving the reduced emission for sustainable production.
Hope you find this video to be educative, so let's remain proactive in our efforts to monitor, manage, and reduce emission in our operation. Together we can build a more sustainable, greener, cleaner planet for current and future generation. Till next time, let's meet in part 3 of this video.